Hi, I'm DJ Ware. On this episode of the Cyber Gizmo, I'm going to extend a little bit on what's going on with memory. We're going to talk about fragmentation of that memory. We're going to talk about paging, and we're going to talk about something called compaction. And of course, we're going to bring swap into this discussion as well. So let's just dive in and talk about what is Linux anyway. Linux is always considered to be a virtual memory managed operating system. But what exactly is a virtual memory managed system anyway? So virtual memory systems there's two kinds of memory. There's physical memory, which is the actual number of chip blocks that your computer has installed in it. So it could have 4 gig, 8 gig, 16, 32, 64, 128, a terabyte. It could have any amount of physical memory. Virtual memory is an extension of physical memory that allows you to run applications which take up more physical memory than your machine has. And how does it do that? Well, it uses something called swap in order to page parts of the program out to disk. So disk becomes an extension of your physical memory. And there's also ways that you can use your physical memory as swap. I personally think that's a bad idea because, and we're going to talk about the fragmentation part of this right now, but because of memory fragmentation, when you're putting your swap file into memory, you're just creating a problem. And you're just exacerbating the problem. You're making it worse. So all virtual memory managed systems are plagued by something called memory fragmentation. That's true of Linux. It is also true of Windows. It's true of Mac OS. It is also true of Unix. It's true of even the older systems like the IBM OS 360, the Burroughs MCP. It's been a problem with any system that has implemented virtual memory. So let's talk about, it hasn't really been solved very well. So over the years, the developers of the Linux kernel have attempted to address this issue. I think the last major fix went in version 5.0 of the kernel. There may be some additional ones because there are some additional things that they have added on to the memory management of the system in the 6.0 series of the kernel. So they're trying to address this issue, but I can tell you personally from firsthand experience that some of those patches that they tried way back in the early 2000s, late 1990s, they had catastrophic results, and they had to be rolled out. They had to be rolled back out, and we had to go back to the old kernels. And some of them they put in didn't help anything at all. It didn't have any effect, no change on the system at all. When your system first loads, your memory is completely unallocated until the first application launches, which is going to be the kernel, and then init will come up after that. And those beginning to get allocated into memory, and memory starts getting used. But when your system first starts up, memory is a blank slate. What happens is that as time passes, applications will come in, they'll allocate blocks of memory. By the way, Linux is a paged managed system, so it manages memory in pages of a fixed length. I believe the default is 4K, and so that is your page size. How much it allocates or keeps together is dependent on an algorithm that we'll talk about later. But as time passes, these programs will take up memory, and they'll start using those blocks of memory for execution. You'll see in this case we have one block of memory left on the right-hand side in white. And then programs exit, and as they exit, that memory is deallocated and put back into the reclaimed pool that can be used by future applications that run. But if I have a big hole that's left in memory, an application that comes in may not need it all. So it may only need one block out of that contiguous block of memory left by the previous program. Now I've got 3 open and then 1 on the outside for a total of 4. So let's say that a new program starts up and it needs 4 blocks of memory. Well, Linux can't allocate, even though there's 4 blocks there, Linux can't allocate. And the reason for that is Linux wants to allocate and has to allocate memory in contiguous blocks. That means I have to find 4 of them together in order to be able to start the application up and running. In this case, Linux can't find the 4 contiguous blocks, so it's going to have to take action. So what kinds of action could Linux take? It could attempt to page out one of the programs if it was marked as being a system that it could roll out, because maybe it's not busy at the moment, it's just waiting on something, and so Linux could roll it out to where's it going to roll it out to? Swap, that's where it's going to put it. And then it could allocate that memory, and when that program came back in, it would get that last slot over on the right-hand side. Potentially, it would get that unless one of the other ones freed up memory before that happened. So, yeah, so everything would be good. But let's say that it can't. Let's say for some reason there are markings that are part of the system descriptions that tell Linux what type of memory block that is. Some of them are non-movable, some of them are static, some of them can't be moved, and some of them are movable, some of them are reclaimable, and there's others that are in there as well. So Linux may fail to find 4 blocks at all, and so what it might do is it might compact memory, and by compaction it's going to try to collect memory segments together and make a larger contiguous block out of it. And so that might appear in the middle. It could appear on the end. It could shuffle 3 down, which would be kind of inefficient, but yeah, it could do that. And then update the program tables on the programs that have been shifted. So yeah, that's one way of doing it. But if it can't move it, now we're into a problem. So the only thing that Linux can do at this point is it can fail to launch the application because of an out of memory error. And that would be bad, right? I mean, you would be looking at your system going, wait a minute, I've got enough memory for this, but it isn't contiguous, and so yeah, you were able to launch the app. The other thing that Linux could do is it could result to OOM. OOM is out of memory, and it's a handler that is in all of the modern Linux kernels that will basically pick an application. There's an algorithm that it uses to do that. It picks an application and then kills it, blows it out of memory, and frees it up that way. That's very drastic, and you don't want that to happen. However, in Linux 5.0, there was a new piece of code called proactive compaction that was added to the system kernel. That can reduce memory fragmentation, and that has been shown up as much as 94%, but only for systems that have either 1 or 2 CPU sockets. So yeah, if you have more than that, maybe not so much. But that gets into pretty complex memory. When you start getting into 4 and 8 CPUs on a motherboard, that starts getting into some pretty complex handling of memory, particularly in how you move memory from one CPU to another. So there's a couple of tools that you need to become familiar with. One is called Buddy Info. It's a proc file, and it shows the amount of fragmentation that your system has. So we can look at it as kind of an eye chart. I'll blow this up for you. But in this particular case, you'll notice there are, and I know the lines kind of continue down, but there's 3 lines here. Top line is DMA, the second zone is DMA 32, and the third zone is normal. So DMA at the top zone, that would be for 64-bit DMA. transfers. DMA 32 is 32-bit DMA transfers. And then normal would be your applications and other things that are executing in the system. The second thing is page type info. That'll tell you information about those blocks that are there and what are their classifications. Are they unmovable? Are they movable? Can I reclaim them? And that list looks a little bit like this. So why do you need swap space? A swap extends your physical memory, I've told you that, and it allows applications to run even when all of the load that you're trying to put on your system can't physically fit in the amount of physical memory that you have available. So once all your physical memory is used up, you can't load anything else. So without a swap file, you are running a 1960s vintage system that didn't have virtual memory. So how does it use the swap? So let's say I have a system with 4 gig of memory. It's a very small system. And I've got 3 programs I want to load. So I load a 1 gig program, one that requires 3 gig of memory, and one that requires 2 gig of memory. So maybe this is a game in OBS that's running, right? And then the top one is the operating system itself. Don't forget, the operating system sits in here too. So the operating system will map how that memory is being used to a table. So it has a table of all the blocks and where you can find them in physical memory, how it addresses physical memory. And you'll notice that some of them don't fit over there because I'm asking for 6 gig of memory. I mean, yeah, 4 plus 2 is 6. So yeah, I'm asking for 6 gig, but I've only got 4 available. So I can't make all those applications resident. That means some of it has to be moved out of memory. And where does it go? It goes to swap. So do you see now why you can't, it's not a good idea to use your physical memory as part of your swap? Because if you do that, then all you've done is you're still running without a swap file, essentially. And in fact, you are creating a problem for your physical memory in that you're filling it up faster because you're sticking, the system thinks that is an extension to physical memory, and it's not. Oh, but it compresses it. Yeah, but it's still using physical memory. It might not be using the full amount, but it's still going to take up physical memory. It's still going to ask for memory to be allocated, and it's still going to contribute to fragmenting the physical memory of your system. So my contention is that's a bad idea. I don't recommend doing that. Use a real disk to house your swap. So swap basically helps out with fragmented memory conditions because it gives Linux a chance and a place to swap parts of the applications out and maybe build a contiguous block of memory that can then be used to allow another application to start running. And so, yeah, there are direct relationships that have been studied over the years that indicate that memory fragmentation is a very serious performance problem. And I have seen many cases where I've walked into customers and started looking at the machine and found, oh, we have a memory fragmentation problem here. They're trying to run a lot more load on the system. Maybe they need to be reorganizing things better. I mean, buying memory back in the day was the last thing you did because it was so expensive. But we played all other kinds of games in order to keep using what we had. Today, memory, of course, isn't quite that expensive, but memory is still gig for gig, terabyte for terabyte, more expensive than a hard drive. So yeah, if you're going to put all your money in physical memory, I don't think that's a really good idea. I mean, you could definitely buy a lot more disk for that $100 than you can physical memory. So that's my point. How large should the swap file be? That's always something that somebody asks. Some places you'll see them recommend 1 gig, some 2, some say it should be the same amount as your physical memory, some say it should be double. So this is what I always say. First of all, the best way to get a handle on this is to monitor how much of your swap file is being used. over time. And you can't make an instant decision and say, oh, well, if I load up all these applications now, this will be the maximum use for the swap file. But you don't ever know how your system is going to get fragmented over time. That's however bring things down, bring things up, that's how that's going to work out. So you really need to monitor the physical requirements of your system to see how much swap file space you're being needed. As a general rule of thumb, when I'm starting out on a system that I haven't studied how the application mix is going to play out over time, I allocate twice as much physical memory and for my swap. That's what I do. Generally, that usually works out good to at least get me to a spot where I know where it should be, and then I can reduce the size of the swap file to what I actually need. But I always start there, and then I adjust it. Sometimes it goes up. Sometimes I have systems where I've got applications that are absolutely huge that need a lot of memory. The swap file versus swap partition debate. So which is better? Well, both will work, but if you go listen to Linus Torvalds, he's talked about this many times. I mean, if there's somebody that's an expert, don't listen to me, listen to him. He recommends swap partition. Now, he must have a good reason for that, right? He doesn't say, oh, swap file, fine, just use that. No, he doesn't say that. He says, allocate a swap partition. That's what he says. But there's some downsides and there's some pluses to using a swap file. First of all, a swap file can be extended. It can be made larger, it can be made smaller, and much easier than you can extend and shrink a partition. And you can do that modification while the system's running. You don't have to restart a swap file to do that. So it's got some advantages, right? So I guess if you're starting out and you're trying to figure out what it should be before you make the allocation to a partition, maybe a swap file is not so bad, right? However, swap files can suffer performance degradation if the file system on which it resides gets busy. Think about it. If your swap file is filling up, it's because of load on your system. So your system is becoming busier, and so it's starting to push more into the swap file because there isn't memory to be able to handle it. That means that more IOs are going to be going out to the swap file. It probably also means there's a lot more IO going out to that disk that swap file is sitting on. So yeah, as it all fits together. So as you pick up load, you pick up IOs. If your swap file happens to be on the part of the system that's being used a lot, then it's going to suffer. I don't need a swap. No, you don't need a swap. You can convert your system to a 1960s operating system if you wish, where physical memory rules what you can run and what you can't. You can do that. Or you could take the chance on having, having programs just blown suddenly out of memory for no particular reason. And you're going, why did that program exit? Did it break? The other problem is without a swap file, if you're trying to hibernate a laptop, you can't do it. It has to have exactly the same amount of memory has to be the same size as your physical memory, or you can't hibernate. So if you're having a problem with hibernation, check your swap file. That might be the first problem that you've got, is it ain't big enough. So the other problem is that you're really narrowing Linux's ability to manage your system to two choices. The first choice is it'll push an error out that says out of memory condition when you try to launch the application. It'll just flat say, I'm out of memory. I can't do anything for you. Sorry, it ain't going to load. You've got an error. The second one is it loaded, but now it's trying to page back into memory, and it can't. So now you have the OOM firing, and it blows another program out of memory. Well, I'm telling you, that's great, but if that happens in production, either one or two, both of those could get you fired, because you're operating under probably contractual guidelines with a customer that is saying, I will supply you with 99.9999% uptime. And if a program doesn't load, that could be a critical piece of your infrastructure. It might be the database that runs your website. And so your website goes down. Or it could be a program that's shot out of memory that might be your web server gets blown up. Or maybe it's the middleware that moves data out of some back end system for display on the front end, and that gets blown out. So yeah, those could get you fired. Not a good condition to be in. So yeah, use a swap file. As far as the tools that you can use to monitor your system, buddy info and page type info will give you some very good information about what's going on. There's also a GitHub page. I'll send it out to you that'll calculate based on your buddy info what your percentage of fragmentation is in your system. I don't know if, I think the rules were drawn up a few years ago, and I don't think they have changed. But if they have, then that program needs to be modified. But it will give you a good idea of percentage-wise on each one of those nodes, like your DMA, DMA32, and your normal, how fragmented your memory is. Is this just old people talking? No. No, this is not just about old people talking about the need for swap. This is how your systems work. I mean, you don't have to listen to me. Listen to Linus. Anyway, that's all I had for today. I hope you enjoyed this discussion on fragmentation and how swap can help. Swap is more than just being a backstop for your physical memory. It does some other things as well.